Come back a little there. A little more. Yeah, webcams just have not evolved at all. Oh, there's some sort of mics on there. Just pop those on too. Could you send me the Vive box, please? Okay, no, I'll do it. Sorry. Oh, it's heavy.
Yes, I think.
No, it's just a stereo mic, so I can point one at either one of you,
Right.
and I will be kind of on the center. For whatever reason, the precise combination of software and cables is actually mixing it all down to mono on the fly.
Mm-hmm.
Okay, say something.
Something.
Okay.
Test 1, 2, 3.
Well, I'm not getting any levels on this, so let's just assume it's okay. Right. Okay, let's do this thing. Right, so, gentlemen. I can't think of anything to say. Okay, so today we're here with Rob Knight and Dominic Tarr. Rob is one of the folks from this new venture capital project that we're putting together, and Dominic is from a project called Secure Scuttlebutt. Do you want to introduce yourself?
Hi. So my name, I'm Dominic. Secure Scuttlebutt is, I think the best thing is that this is a secure gossip system. So a scuttlebutt is the cask that today's water ration is stored in on an old sailing ship. So it has exactly the same connotations of gossip as the water cooler or something like this. Basically it's a protocol where information travels in the manner of gossip from one node to another node and so on. But unlike regular human gossip, it's secure. So one intermediary node can't change what you're saying. So there's no like Chinese whispers problem.
I see. And you personally, how did you get interested in such a thing?
Well, I had wanted to build a platform for distributed applications that works offline and stuff. Part of this was, I think I started on this path. I was living in a swamp, in a sailboat in a swamp in New Zealand, and I didn't have internet on my boat, so the situation of not being connected to the internet wasn't wrong. I needed systems that worked even if you were offline or in connection and like had unreliable connections. Like I grew up on a farm where the best we ever got it was a satellite connection which had like 1 second latency. I don't assume that being always connected is like it's going to happen anytime soon. And then you can daydream that out to be like, well, space exploration, you're limited by light speed, so you're going to be back. It's going to be back kind of like sailing ships
Yeah,
You're not
absolutely.
going to be able to get
Mm.
instantaneous real time.
9,
low
12,
latency.
15 light minutes to Mars.
Yeah,
Yeah, yeah, yeah.
and that's the close one. Jupiter, Saturn, it's like far worse, but
2.5 hours, something like that.
a long
Jupiter?
time. Yeah,
Yeah.
even the second. So like to the moon, it's a second and a half.
Wow.
So
Wow.
um,
Which is just enough to make conversation impossible, right?
yeah,
Yeah.
Yeah.
I'm still kind of stuck on you living on a boat in a swamp.
mm-hmm.
Are you basically telling us that you're Yoda?
Aha. Well, I think you're a better likeness of Yoda, actually.
Somewhere between Yoda and Jabba the Hutt. It's not that funny. Rob, do you want to introduce yourself?
Where to start? So yeah, I'm Rob Knight. I'm working with Vinay on the venture capital project. My background is in software development, software project management, various mixture of interesting and very boring things. I don't live on a boat in a swamp, and so I don't have like that degree of experience with those kinds of exotic conditions. But I think, like everybody, I've kind of seen the same variability in lots of different kinds of internet connectivity over the years, ranging from ancient 1980s modems all the way up to fiber optics and so on now. And it's kind of it. I kind of agree. It's kind of something we've come to take for granted, that connectivity is just always on. It's just kind of there. If it's not low latency and available, we kind of look at it like it's not working.
Mm-hmm.
And actually, that's really just a product of the conditions that we're in. That's not a product of the fundamental reality of engineering these systems for, as you say, interplanetary communications or whatever else it might be. And it's kind of always amusing when you see some science fiction which blatantly disregards the physics involved and does appear to have very long range instantaneous communications. So it's really it's good to be reminded of the actual engineering reality.
Mm-hmm. And also when you look at places outside the first world, basically very crappy internet is the default. You can get it, and even though people might have cell phones, they probably can't afford data. So the infrastructure actually might be there, but
they can't afford access to it.
Yeah.
I mean, this place here, when we initially got it, had 8 megabits of connection.
Mm-hmm.
So, I moved in and it was just about broadband.
Mm-hmm.
Terrible latency, lots of downtime, totally unpredictable. And then about 9 months in, Hyperoptic came up and ran fibre to the building.
Mm-hmm.
And my quality of service, I mean, just in raw speed terms, improved by 125 times overnight.
Mm-hmm.
I mean, it was literally just they threw a switch, 125 times faster. And I can't think of another utility that could potentially have improved by a factor of 125 times. Like, imagine if your mains electricity got 125 times cheaper.
Mm-hmm.
It would go from a bill of, 30 quid a month to, 30 pence a month.
Or maybe going from piped plumbing to having to walk a couple of k's with a bucket.
Yeah, exactly. So it was it was just a huge step function thing for essentially no physical change in the environment.
Mm-hmm.
2 kilograms of matter might have moved
Yeah.
in the form of them running a cable or something, but it was just, there's something magical about that.
Mm-hmm.
But the fact that, in London, 500 metres from a train station, from a tube station,
Mm-hmm.
like in a transport hub with a huge shopping mall nearby and 4,000 or 5,000 people living on the kind of estate,
Mm-hmm.
that they only just got it turned on.
Mm-hmm.
I mean, something very weird is happening.
Yeah. And even as privileged Westerner, you can go travelling and then you're in a strange airport, or like once you're out of your own country, it's a pretty damn good chance that you'll be stuck in disconnected things, or even just a busy cafe. Wi-Fi doesn't, because Wi-Fi just isn't designed to work for a lot of people.
Yeah,
at once.
absolutely. The Wi-Fi is down.
Yeah.
Yeah.
Or it's just too crowded.
Yeah. Yeah.
It's basically like it works on radio, and radio is like shouting, so everyone shouts at once.
Yeah.
Doesn't
Yeah.
work great.
What are those base stations called that are really resistant to that? Barracudas or something?
I'm not sure.
I can't remember. There's one that whenever I see it at a conference, I'm like, oh yeah, that's the good one, the Wi-Fi will work, and if I
Mhm.
don't see that particular brand, it never works. It's
Mm.
something like Barracuda.
Yeah.
So, let's wade into the crypto.
Mm-hmm.
So we've obviously come out of this kind of blockchain frenzy.
Mm-hmm.
You know, first Bitcoin, then Ethereum, now Zero Cash,
Mm-hmm.
layer after layer after layer of this incredibly aggressive innovation.
Mm-hmm.
But in practice, when we use these systems, when you're going to make a payment to somebody, you either look at a web page which has no real security if their server is hacked,
Mm-hmm.
and download their address from there,
Mm-hmm.
or they send it to you over Google Talk, or they send it to you over Skype,
Mm-hmm.
all of which are woefully insecure mediums.
Mm-hmm.
So the problem of how do we bind a key to a person is completely unsolved,
Mm-hmm.
except using these totally informal mechanisms. Now, way back in the mists of time, and by that I mean the 90s,
Mm-hmm.
we had this thing called GPG. And GPG, right, GNU Privacy Guard, before that PGP, Pretty Good Privacy, was a bunch of state-of-the-art encryption, which was enormously offensive to the US government prior to the purchase of PGP Inc. by Network Associates.
Mm-hmm.
Network Associates then reversioned PGP from 2.6.2 to 5, removing all the patented algorithms
Mm-hmm.
and replacing them with a bunch of roughly equivalent algorithms that weren't patented,
Mm-hmm.
after which the US government seems to mysteriously lose all of its hostility to PGP.
Mm-hmm.
I know. Moving swiftly on. Also, by the way, the NIST thing,
Mm-hmm.
just while we're being crypto paranoid. So, National Institute for Standards and Technology takes a cipher that the NSA has backdoored, the cryptographic random number generator, dual ECB deterministic random bit generator, DVRN, whatever it is.
Yep.
Dyslexic acronyms. Right? And everybody is strongly encouraged to use this thing. But it turns out that because it uses an elliptic curve, it is possible, if you know a set of magic numbers which are related to the magic numbers which are inside of the random number generator,
Mm-hmm.
that you could take only a little bit of the output of the random number generator and infer the internal state.
Yeah.
So essentially they ship a backdoor random number generator
Yeah.
because the NSA has the private keys to the random number generator, the public keys are going out to this mechanism.
Yeah.
So people don't seem to have spread that paranoia to the rest of the ciphers of the NIST suite,
Mm-hmm.
but it seems logical that you'd have to.
Well, there were people that pointed out the problem with this random number generator is it needs a setting, a sort of a settings file,
Yeah.
and the settings was like basically you have some numbers that are randomly distributed, uniformly distributed, and they presented like this is the numbers for this one, but they never explained how they got to those, and that meant, well, how do we know those are fair? Like, how do you know that that doesn't have a special property that we don't know about?
Yeah.
And when what's considered the right way to do this is you pick a it's called a nothing up my sleeve number. So you might use the so I think SHA-256 has this. I might be wrong about the specific details here, but it uses the decimal fractions of the first 30 or so prime numbers, of the square roots of the first 30 or so prime numbers,
Yeah.
which is uniformly distributed.
Yeah.
But they can make a good argument that we didn't choose these numbers, they're just
Yeah.
part in the universe.
They're just there. We yanked
Yeah.
it right. That's really interesting.
Yeah.
Nothing up my sleeve numbers.
Yeah.
I hadn't heard of that.
No, neither did I.
Huh,
But
that's cool.
seems like such an obvious idea once you know it.
Yeah. Insert something about the year the Cubs would win the World Series here.
Yeah, exactly. So other protocols have in the NIST suite, like SHA-256 has been very well studied and has things like that. So there's no
No cause for
that's
paranoia?
that's why they're paranoid about that
Yeah.
particular one.
Yeah.
If they'd had a good nothing up your sleeve number in it, then it could be a different story.
Although there's still this problematic thing that you do have strong indications from the structure of the cipher
Mhm.
or the structure of the random number generator
Yeah.
that you do have the ability to have external numbers which are tied to it.
Mm-hmm.
So even if you picked a nothing up your sleeve number, there's still the possibility that you could then do an enormous amount of compute to calculate the set of numbers which
Mhm.
would still allow inference of internal state.
Perhaps, but I think if you don't have a special number, you have to have some secret advanced like number theory,
Yeah.
which the NSA could have because they have a lot of
Mm.
very, very good mathematicians.
50 years of classified mathematics.
Yeah. But I guess at one level, cryptography is people have to choose what experts they are going to expose their risks to.
Yeah.
And at least there is a sense of like, if you choose
Yeah.
like Dan Bernstein,
Yes.
you aren't going to be the only idiot if it gets out.
Yes.
So it's like
Absolutely.
like
Absolutely.
flying on a jetliner versus building your own aeroplane.
Absolutely. No, I mean, I'm definitely massively against people rolling their own crypto. But what I want to establish is an appropriate degree of paranoia.
Mm-hmm.
Because, what we're discussing here is integrity of human communications.
Yep.
In an age when everything is monitored that can because be monitored, and many of the platforms are basically surveillance marketing tools.
Mm-hmm.
So the notion that we have to kind of robustly re-examine the entire ecosystem and figure out where to build,
Mm-hmm.
I think is quite important. So this question of discovering an identity, right? If I want to talk to somebody, I need to retrieve a key.
Mm-hmm.
And right now we're doing that informally by sending the keys over Instant Messenger.
Mm-hmm.
One of the things which hasn't happened yet is large-scale fraud by key substitution.
Mm.
Mm-hmm.
You send me an email with payment details. I naively assume that because the email came from you, the payment details are correct.
Mm-hmm.
Somebody else has substituted a different key in
Yeah.
the email. I make the payment to the key that I think you gave me. Money goes missing.
Yeah.
And although that attack is largely theoretical at this point, once that kind of stuff starts in earnest, unless we've got really strong mechanisms to be able to manage the namespaces, we're not going to be able to do
Mm-hmm.
that. And that question of how do we bind keys to people or keys to organizations,
Mm-hmm.
we currently have an answer for, which is X509,
Mm-hmm.
aka HTTPS, certificate authorities,
Mm-hmm.
and all that stuff basically has a bunch of global keys,
Mm-hmm.
which then become a bunch of national keys, which are then farmed out to the registrars, who use that chain of authority
Mm-hmm.
to sign a key for you when you come and say, hey, I want an HTTPS cert.
Yep.
And because the registrars are economically incentivized to issue certificates, they don't really check stuff properly, and you get things like people getting a fake Microsoft certificate issued in, was it Finland?
Mm.
Which causes all kinds of mayhem, because to all of the computers in the world, until that certificate is cancelled,
Mm-hmm.
you are Microsoft.
Mm-hmm.
So I want to kind of, just map that out a little so people have it in mind.
Mm-hmm.
So that we start talking our way through what Scuttlebutt is and how it will work.
Mm-hmm.
They've got some notion of where it fits relative to the ecology that we currently use.
Yeah.
Because we're actually all using crypto every day, not just in blockchain applications, but anytime you put a credit card into a computer.
Internet commerce would not be possible without cryptography.
Does everybody remember the internet before internet commerce was possible?
Just about.
Mm-hmm.
Children, there was a time when you could not make a payment on the internet. Everything was public, it lived unencrypted on the wire, even typing your passwords into things was not secure, and we lived through this dark age. The 90s.
Mm-hmm.
Because it was, 98, 99 when we got HTTPS?
Mm-hmm.
One of my friends, Samir Parquet, made an enormous amount of money
Mm-hmm.
with a company called C2 that produced a thing called, was it Stronghold?
Mm-hmm.
I think was the first HTTPS web server.
Mm-hmm.
And at the time, this was the Bitcoin of the day, right?
Mm.
We're going to disintermediate everything.
Yep.
Amazon. Right. So, now that we've kind of fleshed out the namespace,
Mm-hmm.
right, and we've got some notion of individuals have a key,
Mm-hmm.
start at the beginning of Scuttlebutt and just give me, just kind of break
Well-
it down. I'm an individual, I got a key pair, what does Scuttlebutt do for me?
So we kind of came at Secure Scuttlebutt after having sort of learnt about how some security and distribution and stuff and database replication and that kind of thing came together, and I saw that there was this quite good idea in PGP, but it was poorly implemented. That it had a trust network, which seemed to me intuitively to be a pretty good way to assign names to keys in a decentralized way. but it brutally failed by not being fun.
Yes.
And
Yeah.
Yes.
now we have
Quite the
like,
opposite of fun.
yeah, they call it a key signing party, but it's not like a party that you or I might enjoy going to. I've actually never been to a key signing party,
I've been to a few. Two long rows of people, mostly still with their rolling luggage or backpacks because they've come straight from the airport to the conference, wherever it is. You know, moving down in lockstep, one at a time, examining each other's passports and typing stuff into their phones.
Yeah.
Yeah.
And another quick note here is that this idea of like examining someone's passport is like, well, that puts who's to. That's one version of identity. You can be all kinds of, you don't necessarily want to be the same person that the government thinks you are.
Yeah.
For example, musicians and artists quite frequently like create a new identity to release new material on, so that they can see how well that stands on its own,
Yes.
without associating it with their more successful name or something like that.
Yep. Yep.
So I sort of I took sort of those ideas, but also the sort of playbook, some moves out of the like Web 2.0 playbook, where in Web 2.0 they sort of, social media and stuff, they design a thing. They don't sell the product, the app, to your rational mind.
Yes.
It's entertainment.
Mm-hmm.
They make a thing that that is just sticky. It's engaging. You use it because you enjoy using it.
Yes.
You don't need to think about why you use it.
Yeah. Yeah.
Why
this is meant to be fun, right?
Yeah, but then you can come by and interpret those things. So you can look at Twitter and you can be like, oh, Twitter is actually a trust network.
Yes.
Because when you follow someone, you are saying, this is an interesting human being or a very clever bot.
Mm-hmm. Mm-hmm.
But if you only follow a couple hundred people, you have been like, these are the usernames that I think are interesting out of the entire internet.
Yes.
That's actually a very strong signal.
Yep. Yep.
Assuming what you think of my opinion, I mean it's subjective, but from my point of view, I'm like, these are real.
Yeah.
And then if those people say that these other things are real, that's a good thing.
So you have this kind of, it's like a preponderance of evidence, weight of circumstance.
You can interpret it like that.
Yeah.
It doesn't mean that the users of Twitter are thinking about that when they do it.
They didn't necessarily build it that way, but that's what you get.
Yeah.
I see.
So I think you should look at like what is when you should look at the meaning of an action in terms of like the way that like Wittgenstein would, of like what does it do, what effects does this have?
Okay, bulk that out a little more.
Well,
I've read many things.
For example,
Wittgenstein is not one of them.
for example, a like button,
yes,
or favorite button on Twitter. What does that mean?
Mm-hmm.
Well,
so kind of in a signs and signifiers way.
Well, just because it says favorite doesn't mean that that's your favorite tweets.
Yeah.
People use it in a multiple of ways.
Yeah. Like I use it for bookmarking.
Yeah, you can use it for bookmarking, but also since it notifies the author of those tweets, it's a way of like acknowledging that to them.
Yeah.
Like it's kind of a way of like you can say thank you to them or be like, I read this.
Yes.
Without adding any extra content.
Yes.
It's a good thing to use at the end of a conversation when you don't want to keep replying and fighting over who gets the last word. You just like the thing that you think is basically the end of the conversation.
Exactly. It's like smile and nod sort of thing.
Yeah, that's interesting.
And like last year there was a time where Twitter tried to drive engagement, tried to turn likes into retweets.
Yeah.
And everybody was like, no, this is like it's not. There's a retweet for a reason.
Yes. Yeah.
And
the same thing with this commenting of tweets that we have now. You know,
where you blink it.
Yeah. And there used to be this kind of fine art of retweeting something and shortening it, and that limited the length of a retweet chain because you could either stop crediting people, or you could, or you just ran out of space as the list of vias got longer and longer and longer.
Yeah.
And so it naturally expired stuff.
Mhm.
which on one hand made Twitter less viral, but on the other hand enforced a certain kind of locality.
Mhm.
And Twitter has now lost all locality. It's
Yeah.
become this single rolling space of global memes.
Mhm.
But I think the locality was a lot of what made it interesting. It felt like a place because, the stuff that kind of got retweeted as the retweet, via chain got longer and longer and longer. The messages got more and more and more compressed and lossy and noisy.
Mhm.
So it gave you this spatiality.
That's interesting.
Mhm.
Have you heard of Paleo Chat?
No.
So David Brin, the sci-fi author,
Mhm.
who also wears a big engineering hat, has a thing called Paleo Chat, which is meant to be a chat room environment, which includes a whole bunch of usability features which make it akin to physical space.
Oh, wow.
Like it's got facing, you can turn towards things,
Mhm.
and you can listen to them in a way that you can't if you're turned away from them.
Oh, that's amazing.
And it's got all kinds of things like this. There's a demo that he's doing for people that I've signed up to a couple of times and I've just never been able to make.
Mhm.
But they have little group demos where you actually get to see Paleo Chat. But he's done a ton of thinking about it.
Mhm.
And that feels to be like it's a really conceptually important thing.
Yes.
I heard about it a few years ago and my antenna were just like, ding! And Paleo Chat.
Yeah. True. Yeah.
David Brin, #1 smart man.
Mhm. So anyway, how this relates to Web of Trust for crypto keys
Ah, yes.
is like if you made basically a decentralized Twitter sort of kind of social media thing, people interact and you can interpret those interactions as signals of
Yep.
trust signals and so on.
Yep.
So basically you can interpret, because of spam, every interaction on a computer is a Turing test. And if you click spam or delete or unfollow that person, that means you have failed they have failed a kind of test.
Yeah,
But
yeah.
the ones you continue to interact with
Yep.
are the identities that are real. And you might know someone only as an avatar and a name, and it doesn't really matter. You can still have a relationship with whatever that is. It doesn't. It's not really a. I think this is one of the nice parts of the internet is that you can have you can present yourself however
Yeah,
you like.
yeah, yeah.
Um,
Right, so you've got this ability to generate these kind of personas, but you're suggesting that they're basically performed into existence.
yeah, exactly.
Mm.
Yeah, and that's one place on a spectrum of identity. That's sort of that's more to one end where you have a pseudonymous performative situation, but I think that is the superset of the you can fit like a global public identity into that just by associating one of these performant identities with your physical body.
Yeah,
Mm.
yeah. That's interesting. So you've got potentially a set of performative identities, but you link them to your physical body as a way of kind of credentialing them, something like that.
Yeah, well, for whatever purpose they deem them to serve.
I'm quite interested in things like certificates of biometric uniqueness, so that you can prove in some kind of zero knowledge way that every single person in an auction binds to a different biological human being.
Yeah, that's a very difficult problem, because so you can, in a decentralized way, you can prove that a public key, you really own a public key,
Yes.
but you can't prove that you own an iris,
Yes.
because iris is a symmetrical cryptography,
Yeah.
essentially.
Yeah. Yeah.
Your fingerprints might be unique, but you leave them on everything you touch.
Yes, absolutely. The password you can't change.
Yeah, exactly. So,
So the approach that I took to this was that you would have things that were like biometric notaries. So you could turn up in a bank or something like that. Slap your keys and your head on the table,
yeah.
and they would then perform the binding for you. And what they would issue would be a certificate of insurance that these two human beings were not the same person. Right? We
Yeah.
have seen A, we have seen B.
Yeah.
Both of our branches verify that they do not have matching biometrics,
Yeah.
therefore they're not the same person.
Yeah.
We can vouch for that. And what they would give you would be a digital certificate ensuring that up to $1 million, $2 million, $5 million.
Sure.
and the more expensive the transaction, the more they would charge for that certificate of insurance. So the business model would be insurance against
Yeah.
identity fraud,
Uh-huh.
and that's what they would use to pay for the hardware.
Uh-huh.
But I couldn't think of anything short of that would work.
Uh-huh. Well, when you get to, like, what is this important for?
Well, so it's incredibly important in situations where you don't want to disclose an identity.
Mm-hmm.
So I walk up to a car rental place with a certificate that says, here's $150,000 worth of insurance that I am known to, let's say, Citibank,
Mm-hmm.
right?
Yeah.
Citibank has my biometrics on file.
Yeah.
Here's a cert. You can verify that that cert applies to me, but we're not
Mhm.
going to give you any of my identity information.
Uh-huh.
So what I get of you is insurance rather than identity.
Uh-huh.
And at that point, you could potentially move through the world relatively anonymously
Yeah.
because your conduct is vouched for by your insurers.
Mm-hmm.
It's a kind of an insurance-centric model, because I only need to know your identity if I want to recover costs against you if you do
Yeah.
something criminal. Whereas if I could just prove that I have insurance to do this, you could just let me run around like a crazy person, because if something goes wrong, you can sue.
Yeah.
Mm-hmm.
And I think that approach, where basically people are preceded by this kind of like, this nimbus of insuredness. I have the nimbus of insuredness. I can absolutely take this jet ski through the streets of Amsterdam,
Mm-hmm.
or whatever it happens to be. Like, you can imagine people being, indemnified to do all kinds of otherwise forbidden behaviour because this nimbus of insurance. Everybody is just like, well, if this goes wrong, we get entertainment and money.
Yeah.
Mm-hmm. I'm not sure that actually necessarily requires biometrics. Like, it doesn't.
Mm-hmm.
The point, I think, where biometric, where like that you are one unique person becomes important, is things where you want to have some kind of voting, fair voting, where this many entities can vote on thing and will pick the most popular answer, and you want to avoid a Sybil attack,
Yes.
which
Absolutely.
is
Absolutely.
Sybil attack was known under many other names as well. Sybil attack is the computer science term, but you have in politics you have astroturfing, where you hire a fake grassroots movement.
Yeah. Yeah.
We've seen some Sybil attacks. You get sock puppets.
Yep.
Where so Gamergate recently was a Sybil attack.
Seas
where-
of sock puppets.
Yeah, massive amounts of like fake accounts pretending to that were really controlled by FIFE, pretending to have a massive support and basically being a big nuisance.
Yep.
And also on things like eBay and so on, you have a problem where you could create a fake version by generating a whole bunch of generating other accounts, pretending to trade with yourself.
Yes, absolutely.
And then it would create a good feedback, and then